What's up, Covalence friends? Today, we're going to be going through the basics of AMQP. I'm not going to waste any time. Let's get right into it. All right, so AMQP, it's Advanced Message Queuing Protocol. It's basically a lot of words for something that's super simple. Now, we're going to be using something called RabbitMQ, which is basically just software written to implement AMQP, as this is really just a messaging protocol. So what is RabbitMQ? Well, RabbitMQ is basically just a program that does this, where we actually have an exchange. RabbitMQ is this entire broker here. It's just an exchange that takes in a message that then distributes it to the proper queue. And then we have consumers that then ingest information or messages from each of these queues. Now we can have consumers listening to multiple queues. We can have them listening to a single queue. And we can have the same thing with producers. Producers will always publish to this exchange, but they're basically going to tell the exchange which queue to transfer this message to. If they don't tell it, then it's going to essentially populate a dynamic queue. And whether or not somebody's even listening to that dynamic queue is up to the people who write the software, right? So we're going to use RabbitMQ, and what we're going to do it with is something called CloudAMQP.com. So if you go to this website, you'll see it's basically just a service provider or a host for RabbitMQ as well as LavinMQ. Now there's a whole bunch of different software services that you can use. We're going to stick with RabbitMQ, and when you log in, it's going to let you log in via Google, Google services, or you could log in with GitHub or something along those lines, or you could just register for a new login altogether. But whatever you choose doesn't matter. It'll eventually take you to this page where you'll have these instances. Where now we don't have any instances right now, so we're going to create a new one. And it's basically saying that we don't have any credit card information or billing information on file, which is fine. You won't need it because we're going to use this little lemur plan, which is free. So we're going to want to name this. Let's just name it Covalence. And tags, we're just not going to really do much. I mean, we could just say something like test for now. And then we're going to go ahead and select our region. Now we can choose Google Compute Engine, AWS, DigitalOcean, Azure. Let's go ahead and use GCP. And we're going to now review this. So let's see, we're going to confirm our new instance. We only want this free instance, which is $0 per month, pretty good deal. And we're going to create the instance. So it's pretty quick, it immediately creates it and we're good to go. Now, what we can do is we can open up this RabbitMQ manager here, which will actually tell us all the current connections, right? So there's actually 7 exchanges in this, which is really nice. We can go to that tab and we can see all of these, right? But for the most part, we're not going to be worrying about any of this right now. These are essentially kind of like default exchanges. So what we will do is go back to overview, if it ever loads. Extremely slow. Let's see. Well, you can see one thing, RabbitMQ is written in Erlang, which is interesting. Let's go ahead and close this and open it back up, and hopefully it opens to that overview tab. All right, so clearly there's some issues with this little page. Now, this isn't super important. This is just kind of a cool thing to have open just to kind of see what's happening. You don't need this open for anything. We can't even get the connection, I don't think. But what we're going to do is we're going to go back to our instances, and we're going to click into this. Now, don't worry about, copying this URL or anything like that. I'm going to delete this instance as soon as I finish filming this, so you guys can try all you want to connect to this, but you're not going to get anything. But what we do is we have the actual URL here. Now what you can see is we can actually see the AMQPS protocol here, which is what AMQP uses. Now that's kind of the encrypted version, right? Kind of like HTTPS. And this is just essentially the protocol used for this messaging protocol, right? So we're going to want to copy this. And we're going to use it in both of our sender and our receiver apps. Now, the whole benefit of using messaging is really more for like a microservices architecture, or you could have some sort of monolithic architecture that just has a small microservice for doing some sort of labor-intensive activity. So think, processing a video, transcoding a video, something along those lines. You could use it for image resizing, right? You could use it for PDF generation. No matter what it is, it's something that you don't want to bog your server down with, that you can essentially kind of queue up and allow for another service or a microservice in this instance to then kind of take it off when it's ready, perform the action, and then acknowledge that it's completed that action. So we're going to pull up a AMQP sender app. Now we're just using an Express template again. I have the link to this template in the description below, but it's essentially just a very basic Express server, right? And so we're going to create a new folder called services, and we're going to create a new file in here called amqp.ts. And let's open up a terminal because we're going to need to install a package. So what we're going to install is a package called AMQP lib, and then we're also going to install the type. So AMQP lib, and we're going to -- save this as well. So let that install real quick. All right, no problems there. And then we're going to start coding. So we're going to import AMQP lib from AMQP lib. And we're going to define a queue name. So for our case, let's just say we're going to call it tasks. That's something common, that you would actually have that essentially is really kind of all encompassing, but generally you might have multiple queues and your different queues will perform very specific tasks, but we're just going to kind of keep it general. Now we're going to create a kind of global variable, and global, I just mean global by global in this file, but it's going to be an AMQP lib channel, right? And so this channel is basically going to be the channel that we kind of publish messages to, right? So this is our sender, remember, this is our sender app. Now we're going to also create a consumer app as well that's going to actually consume these messages, right? Because it really doesn't make sense to send and consume from the same application. You can literally just kind of you could do that if you wanted to, but for the most part, it's probably better to essentially have these as multiple apps, right? It's a better test case or a better use case to have these as multiple applications. Now, you could have it as a monolithic app and then only consume when there's downtime. So that is another use case. It's just less common. But anyway, let's create a counter as well. Let's start at 1. And this is basically just going to be our message index, right? So we're going to just index our messages. And then what we're going to do is we're going to just kind of create a function, an immediately executed function here. And it's going to be an immediately executed async function. And basically all this is going to do is kind of create our connections. So let's do a little try catch block here where we kind of just catch any errors. And we can just console.log, error and E, right? All right, so in our try catch, we're going to establish our connection. And it's going to be amqplib.connect, and that's going to be our URL. So let's see, do we still have, we do. All right, awesome. So we still have that copied. So this is going to be the URL that was just found here, right? So basically this is all that is there. And we are now going to create our channel, which is going to be from our connection. So we can say chan equals await con.create channel, and essentially this is just going to create a new channel, and we don't have to name it or anything like that. It's just a connection to our server or our hosted instance, right? Okay, and then finally what we're going to do is we're going to await our chan.assert queue, and all this does is it asserts that there is a queue with the name that we pass in. So we're going to pass in our queue, which is just tasks. So we're going to assert that this queue called tasks exists. Excuse me, got a little tickle. And then we can pass in options. So you can explore these options all you want. The one that I'm going to show you is called durable. And durable true is basically just an indicator that we want to persist this queue. So basically, if RabbitMQ goes down or if it restarts, a lot of the queues will be destroyed. Now, if we want to save these queues or reload them from memory, we need to pass in this durable true here to make sure that it actually is saved to memory. Or at least that's what it indicates, right? So depending on your actual service provider or host, I haven't looked into what Cloud AMQP does, but they might persist it by default. So you need to look into wherever you're hosting it to make sure and just see. But by passing in durable, you're explicitly saying that you do want to persist this instance. Now, typically what you would do is you might export a function. So let's just say we could export function send, and we're going to pass in a message. and we can check if not chan. Then we want to throw some new error, channel does not exist, something along those lines. Otherwise, we want to essentially, we could console.log the message just to know that we're actually sending it. So we can say sending AMQP message, and then kind of show what that is, right? So we can just show the message. And then we actually want to send it. So we want to say chan.send to queue, and we're going to pass in our queue name and the content, which needs to be a buffer. So what you do is you say buffer.from, and we want to pass in the string message. Now, we could also pass in options, right? So there is one called persistent, which again, this just causes everything to remain in memory, right? Otherwise, it will actually delete that queue or delete the messages from that queue if it goes down. So again, you don't need this. It might be the default behavior of something like Cloud AMQP. And if you honestly are using this for something that doesn't need to persist, then you don't need to actually pass that in. Now, if this is something that's super important, like something like transcoding videos or things that you just cannot, it's basically, it'll limit the functionality or, mess up the actual functionality of your app if it doesn't work, then you want to make sure that these things persist and that, it'll actually pick back up if something does happen to your hosted instance. So again, you want to make sure that that works. And then, so this would be kind of like a send message, and then you could import this send message anywhere, and you could basically just send any message that you want. Now, typically you'd want to probably send something like JSON since we are working with Node, but it is, the whole idea behind AMPQ is kind of like this platform agnostic approach. So JSON, you want it to be some sort of structured data, right? So whether it's JSON, XML, something along those lines, you want it to be something that is parsable and can, essentially send large amounts of information that isn't just one big long string. But what we're going to do is we're going to send just a string just for demonstration purposes, and not to get too complicated, but we're going to set an interval, and we are going to send something every, let's just say 3 seconds. And so this interval is going to just send a message. And what you could do is you could actually, since we're throwing an error in this, we'll do an async function, and we'll put a little try catch block in here too. And we'll console.log e, and then in here we're going to send, and the message is going to be message I. All right, so, and then we're going to want to increment this. So let's just go ahead and message I++ it. All right, so this will end up sending the message, and we're going to be incrementing this counter, and every 3 seconds we're going to be sending another message. Let's decrease it to 2 seconds, just so that we can actually send a good number of messages and not have to wait too long. All right, so if we were to run this, nothing would happen because we're not actually importing this file anywhere. But what we're going to want to do is we're going to want to pull up this index.ts here. We know that this is being imported because this is where we configure the app, and all we need to do is we just need to import /services/AMQP, and just by importing the file like this, we're not actually importing send. Typically you would import the function send, but since we're not actually using the function send, we're just going to have this set interval here. Now obviously you wouldn't want this in production, this is just an example, but by importing just the file, it is going to automatically run this function, which will create this set interval, and we're going to start sending messages every 2 seconds. So we have our file imported. So now if we actually ran this, we would immediately start sending messages up. So let's go ahead and jump into our AMQP consumer next. So let's go ahead, pop this open. We have AMQP consumer here. And we're going to do something very similar. So let's go ahead and pop this sender back open, and we're going to copy this whole file. And then we're going to let's first install. So sorry, I'm kind of jumping around here, but let's npm I AMQP lib and at type/AMQP lib, and then -- save. All right, and then we're going to make our new folder services, and then our new file amqp.ts, and we're going to copy everything, right? Now we want to make sure the queue is the same. We don't need this I anymore. and we don't need this function send anymore. But we do want to make sure that the connection is obviously the same. Now, you'd put this in an environment variable, so you wouldn't be hard coding this in the file. But again, we're just kind of keeping this as simple as possible for demonstration purposes. We are not going to need this set interval anymore. So we do have our channel created. And just so you know, you can actually, instead of asserting a queue, you can actually connect to either an exchange or a queue, right? Which is kind of cool. So what we're going to do is we're going to connect to our queue, because what we want to do is we want to be having our instances ingesting a single one of these messages, right? So we don't want all of our consumers receiving each message. We want each consumer receiving each message once, right? So basically, if we push 20 messages to the queue, like message 1 through message 20, then we want each actual consumer to receive only one of the messages once, right? So basically if we have 2 consumers, right, we're going to spin up 2 instances of this on different ports. And if we have 2 consumers, then we want one consumer to receive message 1, 3, 5, 7, 9, etc. And the other consumer to receive 2, 4, 6, 8, 10, all the way through 20, right? And so that's basically how we'd want it to work. Or, depending if one was able to finish faster than the other, it might not be in that order, right? But if we are going to acknowledge immediately, which I'll get to that in a second, then we would want them in that particular order. But let's go ahead and we are going to basically console.log here and just show that we are consuming this queue. So we're going to be consuming the queue tasks. And then we are going to consume, and we're going to use that queue tasks, and then the function is going to pass in a message. And with this message, we can actually check, right? If message does not equal null, then we're going to do something with it. So we can console.log, and we can say received message.content.toString. All right, now this is basically going to be a buffer. So this is the buffer that we sent, and then the toString method is going to convert it to be a string. So this is essentially where you could perform some sort of intensive operation. So like we said, whether it's transcoding a video, whatever it is, it would happen here. And then whenever that operation is complete, you would actually say chan.ack_message. So you're passing in that message object, which is an AMQP lib.consume message object. So you're passing that back, and it's going to send some sort of message ID back to your provider, and that's going to acknowledge that that message has been received. Now, if this acknowledgement never gets sent and it loses the connection to this instance, then that message will be sent to another consumer to be completed, right? So until that's actually acknowledged, that message is not completed, right? Now, it will wait a while. I think it'll wait by default something like 30 minutes or so for an acknowledge. And if the acknowledge doesn't happen within 30 minutes, it will send it to another consumer, and it'll basically cancel that. So it's essentially a timeout. So if you do need to wait longer, so some video transcoding might take hours, right? And so if it needs to be longer, you need to reset that timeout or tell it not to have a timeout. But again, you just want to make sure that this is essentially, working in the way that you need it to, right? So again, you would acknowledge this. Once it's acknowledged, it actually deletes the message from the queue tasks, in our case, and it moves on to the next thing, right? So then this will actually request another item. So it'll request something new, and then it will be sent the next message in the queue. So it's really awesome actually how this works. I feel like I'm making it a little bit more complicated than it really is. But again, it is a very useful tool, and it is something that, has a lot of different use cases in modern applications. So let's see, if the message is null, then we could just log something like, consumer canceled, something like that, right? So consumer canceled. All right, so it shouldn't actually be receiving any more messages after that, technically. So that could be an issue. You might want to implement some sort of heartbeat, or maybe I'll do a future video on that as well. So again, this is actually all we really need to be doing for actually consuming, these messages, right? So immediately it connects and it just basically waits. So let's go ahead and we need to, just like the other sender application, we need to make sure that we import this somewhere. It really honestly can be imported anywhere, but it's going to be the exact same file route, right? Okay, so this is basically our consumer, and then we have our sender. So what we want to do is we actually want to start up our consumers first. And the way that we can actually do this is we can basically create, let's see, I want to start up 2 different ports here. So how can I do this? Give me a second. You know, there's a way to do it. Let's see. I'm not super familiar with PowerShell. All right, let's see. I know there is some sort of thing like env port equals 3001 and then node. All right, well, first we need to actually run npm run ts. Let's compile everything first. That works. All right, let me see if I can remember this because I cannot seem to find it real quick. Let's see, port 3001, node index.js. All right, let's see if this works. And it worked. Awesome. Consuming tasks. Perfect. All right, so basically all we're doing here, you don't need to do this. This is just really for demonstration purposes, but I wanted to start this instance twice. And so I wanted to start it on port 3001. And so I actually just set the environment variable to be 3001, and then I ran our start function, which is just node index.js. And so what I'm going to do is I'm actually going to create another PowerShell here, and I'm going to do the exact same thing. So I'm going to say env port equals 3002 node index.js, and now we have 2 instances, one running on port 3002 and one running on port 3001. All right, now finally, the last thing we're going to do is we are going to run the, let's see, the sender app here. So let's go ahead and we're just going to run npm start. It'll compile the TS and start the server, and we should start see it posting messages. So we are going to immediately, hopefully, yep. All right, awesome. We got message 1, message 2, message 3. So it's sending messages right now. Now, if we go to this RabbitMQ manager, you'll actually see that this overview looks significantly different now. We actually have 3 connections, 3 channels, 7 exchanges, right? And so it's actually created different channels and it's posting to different queues. So that's pretty awesome. All right, so let's see where we're at. Message 15. Let's let it go to message 20. All right, message 17, 18, 19, 2 more seconds, 20. All right, we're going to go ahead and we're going to cancel that. All right, so we've sent 20 messages. There should be 1 less connection now. But if we look now at our 2 instances, we'll actually see that our server running on port 3001 got message 1357, right? If we keep scrolling, why won't it scroll? Anyway, 9, 11, 13, 15, 17, 19. And the other one will receive the others, right? So it'll receive 2, 4, there we go, 2, 4, 6, 8, 10, 12, yep, 12, 14, 16, 18, 20, right? So it received all of the even ones, right? So it received it perfectly. The actual broker passed off everything to the right consumers, and everything worked really well. So we can actually see that this was consuming things. If this was a performance intensive operation, you know, one of these might take longer than the others. And so you might not have it perfectly balanced like this, because if this one takes a minute and the other one took 20 seconds, then the 22nd one is going to be able to do 3 of these messages in the same amount of time that this one instance will be able to perform this one, right? So again, this is really awesome how the message queuing works. And obviously it works really well, and it also will wait until this is actually acknowledged before it sends another message. So again, everything worked according to plan. And if we pull this up, we can now see that there's no actual operations going on. We still have two channels, two connections, both consumers, and they're sitting there and they're just waiting for additional messages to be sent. All right, so I feel like that was a pretty basic explanation to a fairly simple yet powerful concept, right? And so you can imagine how you could take something like a flexible node environment and you could spin up servers based off of how many messages that you actually have in the queue, and you can continue spinning up servers until that queue dies down, at which point your flexible environment could scale back down, right? And so you could actually create a very powerful microservices architecture for doing very labor-intensive operations. Like I think I said before, something like video transcoding, image resizing. Image resizing, you'd have to be very large images, right? But you could have PDF generation, just things like that, right? So, or anything that involves GPU operations, right? And so again, I think that this particular demo was about as basic as it can get, and it was really just supposed to be introductory material to get you kind of using something like Cloud AMQP as a service, and then obviously you can you can use their paid version, which is going to give you even more channels, more connections, more queues, available at your disposal. But if you need it for something simple, I feel like the free tier honestly gives you quite a bit. And yeah, so if you haven't, checked them out, I highly recommend you just download or sign up for their service, play around with the free tier, just like we did today. And yeah, let me know or let us know how it goes. And if you have any further comments or questions, feel free to drop them below. Check out our community membership, which is honestly all of our courses for the low price of just $25 a month. It teaches you everything you need to know, from a full stack perspective. And also check out our merch store as well. So all those links are in the description below. We love our merch. We love our demos. We love our lessons. And honestly, we love you guys the most. So please let us know what you think and come back soon. Get out of here.